Look up at the night sky. Composed of charged particles, stream out from stars at incredible speeds, carrying with them a fraction of the star's mass and energy. Shaping of entire galaxies, stellar winds are a fundamental part of the cosmic story. Imagine a star, a colossal ball of plasma held together by its own immense gravity. This gravity is so powerful that it pulls everything towards the center, creating a core where temperatures soar to millions of degrees. Deep within its core, nuclear fusion rages, fusing hydrogen atoms into helium and releasing unimaginable amounts of energy. This process is the very heart of a star's life, providing the light and heat that we see from Earth. This energy, in the form of radiation, pushes outwards, constantly battling against the inward pull of gravity. It's a delicate balance, a cosmic tug-of-war that keeps the star stable. This outward pressure is what prevents the star from collapsing in on itself. Without it, the star would implode under its own weight, leading to a catastrophic end. But it's also the driving force behind stellar winds. These winds are streams of charged particles that escape the star's gravity and travel through space. As radiation streams outwards, it imparts energy to the star's outer layers, causing atoms to become ionized, losing electrons and becoming electrically charged particles. This ionization process is crucial for the formation of stellar winds. These charged particles, no longer bound by the star's gravity, are flung outwards into space, forming the stellar wind. This wind can travel vast distances, influencing other celestial bodies it encounters. The strength of this wind depends on the star's size, temperature, and magnetic field. Larger stars with higher temperatures and stronger magnetic fields produce more intense stellar winds. Hotter, more massive stars have stronger radiation pressure, resulting in more powerful winds. These winds can shape the star's surroundings, carving out regions of space and affecting the formation of new stars. Magnetic fields like those found on our Sun also play a role, channeling and accelerating these charged particles into space. The Sun's magnetic field is a dynamic force, constantly changing and influencing the solar wind. Every second, our Sun loses millions of tons of material to the solar wind, a testament to the immense power of these stellar exhalations. This loss of material can have significant effects on the solar system, including the shaping of planetary atmospheres. Over their lifetimes, stars can lose a significant portion of their mass through this process, influencing their evolution and ultimate fate. The mass loss can determine whether a star ends its life as a white dwarf, neutron star, or black hole. Our Sun, the anchor of our solar system, may seem like a benevolent presence, bathing us in light and warmth. It is the source of energy that sustains life on our planet, driving photosynthesis in plants and influencing weather patterns. Without the sun, Earth would be a frozen, lifeless rock drifting through space. But it's also a source of constant, though usually benign, bombardment. The sun is a dynamic and volatile star, with its surface roiling with intense magnetic activity. Solar flares and coronal mass ejections are just some of the dramatic events that occur on its surface. The solar wind, a stream of charged particles, primarily electrons and protons, constantly flows outwards from the sun, reaching us here on Earth. This wind is a continuous outflow of solar material that carries with it the sun's magnetic field, extending far beyond the orbit of Pluto. This wind, traveling at speeds of hundreds of kilometers per second, carries with it the sun's magnetic field. These particles can interact with the magnetic fields of planets, including Earth, creating a variety of effects. When this field interacts with Earth's own magnetic field, it creates a spectacular phenomenon, the auroras. These natural light displays, known as the northern and southern lights, are caused by the collision of solar wind particles with Earth's atmosphere. These shimmering curtains of light, often seen in high-latitude regions, are a visual reminder of the sun's influence on our planet. The colors and patterns of the auroras can vary, creating breathtaking displays that have fascinated humans for centuries. But the solar wind can also be a source of disruption. The charged particles can interfere with the operation of satellites, affecting GPS signals, communication networks, and even the functioning of spacecraft. Intense bursts of solar wind known as solar storms can disrupt satellites, interfere with communication systems, and even cause power outages on Earth. These storms are the result of massive eruptions on the sun's surface, releasing vast amounts of energy and particles into space. In 1989, a particularly powerful solar storm caused a widespread blackout in Quebec, Canada, highlighting the potential impact of these events on our increasingly technology-dependent world. The storm induced electric currents in the power grid, leading to a cascade of failures. However, Earth's magnetic field acts as a shield, deflecting most of the harmful radiation from the solar wind. This magnetic shield, known as the magnetosphere, extends thousands of kilometers into space, protecting our planet from the sun's more dangerous emissions. This protective bubble, called the magnetosphere, is essential for life on Earth. Without it, the solar wind would strip away our atmosphere, making it impossible for life as we know it to exist. The magnetosphere is a crucial component of our planet's defense system, ensuring that we can continue to thrive under the sun's tempestuous breath. Section 4. Cosmic hurricanes when stars rage. While our sun's solar wind is relatively tame, some stars unleash winds of unimaginable power. Massive stars, much larger and hotter than our sun, blast out stellar winds thousands or even millions of times stronger. These stellar hurricanes can carry away vast amounts of mass, influencing the star's evolution and shaping its surroundings. One of the most extreme examples are Wolf-Rayet stars, incredibly hot and luminous stars nearing the end of their lives. These stellar behemoths blast out material at incredible speeds, losing the equivalent of the sun's mass in just 10,000 years. These powerful winds carve out huge cavities in the surrounding interstellar medium, creating breathtaking nebulae visible across vast distances. The remnants of these stellar explosions, enriched with heavy elements forged in the star's core, are then recycled back into the interstellar medium, seeding the formation of new stars and planets. Thus, the death throes of these massive stars, fueled by their powerful winds, contribute to the cycle of stellar birth and death that drives the evolution of galaxies. Section 5. Sculpting worlds, the hand of stellar winds. Stellar winds don't just impact stars, they also play a crucial role in shaping the planets around them. During the early stages of a solar system's formation, when a young star is surrounded by a disk of gas and dust, stellar winds can influence the composition and evolution of planets. These winds can blow away lighter elements like hydrogen and helium from the inner regions of the disk, leaving behind heavier elements that form rocky planets like Earth. Further out, stellar winds can influence the formation of gas giants, stripping away their atmospheres or pushing them into wider orbits. Even after planets have formed, stellar winds continue to interact with their atmospheres. On Earth, our magnetic field protects us from the worst of the solar wind, but some particles can still penetrate the atmosphere, leading to the auroras we observe. However, planets without a strong magnetic field like Mars are more vulnerable. Over billions of years, the solar wind has stripped away much of Mars's atmosphere, contributing to its current cold and arid state. Section 6. Stellar Fury Unleashed, Cosmic Cataclysms. While stellar winds are a constant phenomenon, some events can unleash their power with terrifying force. Coronal mass ejections, or CMEs for instance, are colossal eruptions of plasma and magnetic field from the sun's corona, blasting billions of tons of material into space at incredible speeds. If directed towards Earth, a CME can trigger intense geomagnetic storms, disrupting satellites, communication networks, and power grids. In a worst-case scenario, a powerful CME could cripple our technology-dependent society, causing widespread chaos. Even more powerful are gamma-ray bursts, or GRBs, the most luminous explosions in the universe. These events, thought to be caused by the collapse of massive stars or the merger of neutron stars, release immense amounts of energy, primarily in the form of gamma rays, in just a few seconds. If a GRB were to occur within a few thousand light-years of Earth, the intense radiation could strip away our atmosphere, leaving our planet a barren wasteland. Though rare, these events highlight the immense power of stellar winds and the potential dangers they pose.